you should have a measuring tape and you should center the cap according to the measurement. But for a quick demonstration, you can use approximately 2 finger gap between the eyebrows and the ground electrode. So that gives you a fair enough approximation to record the signal.
Once like the cap is placed, ensure that it is tightly pinned over the head, because when the cap is loose, you have to put in more gel to maintain the resistance level between the electrodes and the cap.
So basically, this is a salt solution gel. So we apply gel in these sockets.
So we'll be putting these electrodes onto the cap. Now, for proper signal collection, the tip of the electrode should be in contact with this cap, and the impedance should be below a certain threshold. So in literature, generally the threshold is around 50 kilo ohms. So the impedance between the scalp and the electrode should be less than 50 kilo ohms for good recording. Otherwise, you'll get a lot of noise and your data will not be accurate. So for that, we use this high viscosity gel.
It looks something like this, and it is highly dense, and it is completely made of salt and water. So
it's completely safe.
So now what we just use a stick to remove hair out of the way, because we want the electrodes to be in contact with the scalp, and we'll just use this gel to ensure conductance, and then we'll fit the electrodes on. Then
software which the company provides us. So this, you can see, this is diagram. So
we have a wireless recording system with us.
So connection is through Bluetooth.
There are multiple ways to record. You can either have a wired machine or a wireless machine. So currently we have a wireless machine, and it also comes with a capability that you can put in a SD card and record it on the machine itself instead of connecting it to a laptop or a computer system to record. So
this is the most important part of this machine, because this connects the electrodes to the machine basically. So
and it is the like point from where all the data from all the electrodes come onto that machine, and then it is relayed to the computer.
So these are the ground and the reference electrodes that I was talking about.
The black one is the ground electrode and the blue one is the reference electrode. So ground electrode is the electrode on respect to which all the values are calculated, and reference is a electrode which is used to remove all the common noises. So as in an environment there are a lot of noises, we are surrounded by very high frequency and low frequency EM waves. So to remove all those noises, we use the reference electrode. So as you can see, this blue colored tip is at the forehead. So this is where the reference electrode goes, and the forehead, center of the forehead is where the ground is.
The reference electrode is the most important electrode. If it stops functioning, all the other electrodes will stop functioning. So we will start putting the electrodes on the head. So first, we'll start by putting the reference electrode and the ground electrode, because these are the most important things.
And so here is the recorder software that Brain Vision provides. So in this, we have various options, and based on which type of cap and device you have, there are multiple options to select that. So here we have a 32 channel electrode machine. So as you can see, the working space which I have is CLA 32 as it is written here. So it refers to the 32 electrode recording machine. So as soon as you spoke to software, a window will be popped up where you have all the options of various recording types. So first is wireless. The next is the live amp memory if I insert a memory card. And the third one is lead off detection and impedance setting for active and trial. So as we have told you about 50 kilo ohm being the reference, so here we can have those values set. So as you can see, we have 25 kilo ohm as a good value and 60 kilo ohm to be the bad value. And this is how we ensure that our like all the impedances between the electrodes and the scalp is within the range that we want. So as soon as you click search for live amp, you have the option of the machine, and you can just connect it to and yeah. So as I have now connected the machine, and this is all the electrodes. So as you can see on the top we have the ground electrode and the reference electrode, and these are all the 32 electrodes that we have for recording, and they are labeled like FP1, FP2, F7. So all the odd number electrodes like F1, F7, F3, they are on the right left hand side of the scalp, and all the even number electrodes are on the right hand side of the scalp. And these naming like FP1, then you have C3, and like you have in the back O1, O2. These corresponds to the different lobes that are present in the brain. So F corresponds to frontal parietal. Then you have occipitory lobe. Then you have central lobe. So the naming conventions goes like that. And as you can see, all the electrodes initially are displayed on the gray color, and they are not associated with any value. But as soon as you connect it on the forehead with appropriate amount of gel, you have these color indications on it along with the value. So these values are the positions where you need to fit it. So like if I can show you, FP2 is the 32nd according to the cap, and we have this as the 32nd electrode, and this corresponds to FP, and so on and so forth. All the electrodes will be placed, and we have the impedance monitoring system on it as well. So as you can see, currently FP1 says 0 kilo ohm. FP1 and in the bracket and like just beside it you have 0K. So that means it is almost negligible impedance between the electrode and the scalp. And as you can see, for ground it is currently at 8 kilo ohm and 44 kilo ohm for the reference. And you can also see the color changes as their like impedance values change. So as we have said, 25 to be like good level. So 0 to 25 is dark green color, and it slowly goes to red as it increases till 60. On the right hand side you can see the range here. So 0 to 25 is here is the range, and we'll just wait for the electrodes to be ideally in the range from 0 to 45 or 50, and then we'll continue with the rest of the thing. So till the time we have like electrodes being in place, I'll demonstrate you software that we are currently developing for analysis of the EEG waves that we have already recorded in our lab. So this is how the application starts, and there are multiple options with which you can analyze the brain signals. So I'll show you some of our past data. I have added one of the files that we have recorded, and as we have mentioned that we have 32 channels for recording and 3 additional channels. So in this bad channel section, you can see like all the names of the channels are mentioned, like F1, FZ, F3, F7, so on, and we at the end we have X, Y, Z direction. So basically, these 3 are of great use when you have a like experiment in which the subject needs to move and you have to synchronize your EEG waves with their movement. So this comes from the accelerometer that is placed inside the machine, and with that accelerometer we have the values of X direction, Y direction, Z direction. So I'll show you. So as soon as you like add the file, there are multiple options here. You can either cut some particular section and merge some section. So as you can see here, there are 2 types of cutting mechanisms. One is based on the time and the other is based on markers. So what are these markers? So markers are basically some annotations we put on the data as we are recording it, to make it easier for us to understand at which point what was happening with the subject. So let's say I have a experiment in which I show them 7 videos, and I need to like simultaneously record where did I start a video and where did I end a video. So for that we have markers. So as you can see, here are all the markers that we have placed. New segment is the name of the marker that signifies the start of the EEG recording, and end segment is the marker that signifies the end of the recording. And all the rest are like comment slash start, comment slash stop. So in our experiment, we are annotating it in 2 ways, where the stimuli was initially given and where the stimuli was over. And then there are various tools like filter tools. So we have to do a lot of filtering of these data, whatever we record, because like there is the EEG system and the EEG recording is susceptible to a lot of noises, because it is based on like EM waves, and there are a lot of electromagnetic radiations that are like present everywhere. So some of it is cancelled by the reference node, but still there are various. I'll show you with some graphs. So this is how unfiltered EEG data looks. So as you can see, it is not very like you cannot understand anything from it. It's the spikes going on and off. So we have this filtering option. I downsampled the data and reduced the and put a bandpass filter of 4 Hz to 45 Hz, which allows only the like signals which are present in the range of 4 hertz to 45 hertz, the signal is now much clear, and it is much like you can observe some patterns if you perform some analysis on the data. And there are other plots as well. So like butterfly plot is basically you put all the signals on a common reference line, and there is topomap. So these are the activation regions in the brain on a particular instance, and this changes with the time. At particular time, 1 minute 20 seconds. This is how the like activation works in the brain. And for other time instance, it was this. And we have also the CSE plot. So CSE stands for power spectral density. And as my friend mentioned here, that there are majorly bands alpha, beta, gamma, theta, and as you can see here are all those like activation zones for different like those bands. So like delta band, theta band, alpha band, beta band, and all. So as they have already put all the methods, I'll switch back to them.
You can see over here that here are some electrodes that are properly connected. Yellow is acceptable because we have set the green range to be around 25. So yellow is acceptable, but for the red electrode, we just need to again remove it, put some gel, and attach it properly.
So as now all the electrodes are placed and they are in the like ideal range under 45 under 50 kilo. So now we can look at and monitor the data. So for that we have various options here. So I'll just turn on the monitoring mode, and this is how the data looks in real time. So
Sukesh, can you blink your eye rapidly?
Yeah, it is being seen.
So as he's blinking his eyes, you can
see the strobes that are formed at regular interval is the blinking of eyes. Now, as you ask the subject to close their eyes, so you can see the waves are quite stable now. These are the X, Y, and Z electrode that the accelerometer that we are talking about. So this is related with this machine. So as I move it, you can see that changes coming over here.
What happens in case of different emotions like anger and all?
Yeah, so
EEG emotion, like EEG data is quite complex, so you cannot really look at it and tell that the person is happy or not. But if the person is in like relaxed state, you can see that all the lines are like straight. But if the person is not in a relaxed mode, then you can see like disturbances.
Initially, you have mentioned that you can use these recorded data for many purposes like emotion detection and all that. So how are you going to do this?
So basically, first we'll do signal processing of these EEG signals. After we've extracted features from these signals, we'll put it in some machine learning model or deep learning model, and the model will basically learn the features.
this data that you are seeing right now is being collected at the rate of 500 hertz per second. So there is a lot of data that is being recorded for every second.
Can you predict that he is lying or not?
Huh?
Can you predict that he is?
Actually, that is something that we are working on it right now. The algorithms are not ready yet, so I'm not able to demonstrate right now. That is something that is.
But based on our observations, when a person is not lying, the lines are pretty straight. But if the person is lying, it goes down. Some of the lines.
There are particularly some of the electrodes that show much more activity as other electrodes.
Lines are distorted due to other reasons. Yeah, from light. Yeah, due to other reasons as well the light was distorted.
Yeah.
We cannot
directly say that it is
So that is why there are many features that we extract out of it, like power spectral density is one of them. We break this signal into 4 bands, as I was talking. We have observed something in the research that alpha and gamma bands are the ones that are more related with emotions as compared to other bands.
just know about the signal processing. So have you done it?
Yeah, the terms that we're using, power spectral density, ICA, these things are basically signal processing only.
So in
These are
ICA,
ways to extract
you try to break down this, like we have 32 plus 300 data. Now, and the sampling rate is 500. So even for a machine learning model, it's not easy to train it on such a large amount of data. What we do is we first downsample the data to around 125 words, and then we perform independent component analysis. So what we do is we break these 32 channels of data into 10 channels or 15 channels.
So you'll be using the machine learning model on this live data.
First we record it.
Yeah.
So there's an
And
option.
then you'll be signal processing, and then you'll apply it as input to the machine.
Yeah.
So expectation is that like models like LSTM or transformers can be the best suited for EEG signals because this is sequential data.
Thanks, Steve. So,
Can you explain? So yeah, as he is putting a lot of strain on his teeth, you can see the signal gets highly distorted.
So this is one of the reasons, like the signal is getting distorted, but it has nothing to do with brain activity.
so when we collect our data, we ask the subject to be really calm and just focus on nothing else except the video that we're showing, so that only the emotion that the video is trying to trigger in them, it like gets recorded.
That is pretty much from us. So any other doubts or questions that you like to ask?
And can you demonstrate like giving him a problem which requires him to think about it? Some problem which is not easy to solve and some problem which is easy. So what changes will this need based on the problem of how difficult it is? Because it will involve brain thinking.
So again, as I was talking, so you see the signal changing over here. You can see some spikes and some troughs. But as I said that this data is getting collected at 500 hertz, and it is not possible to just look at it and try to identify something because it can be related to a lot of things. So as I said, you have to extract features over some short spans of time, like power spectral density or breaking it into separate bands. So even if you now give him some problem, if you observe the EEG signals, so it will be some spikes and troughs, but you will not be able to differentiate it just by looking at it. That is why it requires something like machine learning or deep learning to classify the emotions. Otherwise, classical like CP programs would have worked for classifying it.
So, Professor Vasima, so what is the background of these students?
They are basically third semester and
BTech. So they have some knowledge of machine learning, deep learning, and all.
the fifth semester students are still learning machine learning, but third semester students are not having any background of machine learning.
Any other questions? So right now, we performed a few steps and did some band analysis on the data that we collected. So on the data that we have right now, by performing simple convolutional neural networks, we have a classification accuracy of around 90%. But there are two things to it. Firstly, it is possible that our data might be skewed because multi-class, multi-level classification is something that is very new in this domain. It has not been worked upon a lot. So this is probably the first data set that we are making in the multi-class and multi-level. So multi-level means when you have more than one emotions to classify, and on each emotion you are rating it on a scale of 0 to 5. So that is multi-class. So multi-level, multi-class. So right now we are also making a parallel data set with different set of videos, and we'll use that as a test database for the model that we have. But right now with a simple convolutional deep network, we have accuracy of around 90%.
If you want to improve the accuracy, then what you will do?
Yeah, so as I was talking, so these are sequential data. So first of all, LSTM models can be useful, that is long short-term memory models, and also we can explore transformers, because both of them are suitable for sequential data.
What sort of problem you would like to solve from that particular thing, or like it's related to the light detection, or sort of? So when do you think that your model is complete? What sort of problem it should solve that you might?
If you talk about the use case of this particular algorithm that we are trying to develop, so if a person visits a counselor, say for depression, or not just depression, there can be many other things like dopamine deficiency, because nowadays it is very easy for a person to get addicted to a lot of things, and it may not necessarily always result in depression, but there can be a lot of other things. And so if a person visits a counselor, so what counselors try to do is to interact with the person and to gain trust, and then understand the mental state of the person. But this is a time-taking process and may not always result in success, because everyone has varying times before which they can trust a particular person, and they were not open at all about certain things that may be useful for solving their condition. So our aim is to develop these algorithms to help people with these kind of problems. So if a counselor asks something to the person, even if the person or gives some stimuli, say shows a video to understand the current mental state, even if the person is not very open about what he is feeling right now, but the algorithm should be able to give a fairly accurate idea of the mental state of the person, and then they can be matched with the responses given to the counselor, which can help understand that where a patient has reached in his journey for recovery, or are we able to accurately determine the ailment or the problem that the patient is facing with. Other than that, for the lie detection part, it can be useful for the law enforcement agencies too, because currently the method that we use are using some drugs or heartbeat or pulse to test whether a person is lying or not. As you might have heard about narco test
Yes,
being
sir.
conducted. So these are drugs that are given to a person so that he is not in a state to lie and what he speaks is true. But then there are many ethical and moral questions about using such process, and their accuracy is also, I would not say questionable, but it's not a proper procedure that we have established. So even a person under the influence of drugs can lie deliberately. So in those cases also, our algorithms might be used.
Showing the video to the subject and capturing the emotion.
Yeah.
You have applied it to this particular application.
Yeah, exactly.
The softwares you are using, you develop on your own end, or you are using
Some of the software, that the recording software that we've shown is provided along with the machine that we are using. So, like the manufacturer of these machines sell these proprietary softwares to record the signals, and other software we are also developing the analysis too.
As I'm able to see, this is difficult to understand for a person which is not in technical knowledge. So how will you make it easy to understand to this person?
Our tool is basically for researchers only, like it's
Doctors and researchers.
doctors, researchers, and the people who are in this journey.
Right now we are not that everybody can use, because even the instrument for capturing EEG signals to a reasonable accuracy are quite expensive. So that is why we are not moved in that direction.
So how many types of
So it's happy, sad, disgust, thrilled or excited, anger, fear, and love.
This was one step. So like we have placed the electrodes and we have recorded it. But like one of the most time-consuming processes in this is maintaining the machine to its state. So there's an extensive method how to clean that cap, because these salt solutions stick along with the like electrode. So you have to clean it thoroughly to like maintain the life of the product. So for that, we'll demonstrate how to clean the equipment. Clean the equipment, you need a like box or jar full of water and some brushes.
The outer layer that you see on the electrode is ceramic and water, so we can directly dip the electrodes in water. And also, if you want to test if the electrodes are working properly or not, you prepare a salt solution and you just dip the electrodes and check if all the electrodes turn green.
So this cap needs to be washed after every recording, because residues of the gel is like gets stained along with the holders of the electrode, and we have to wash it. So, and also it's a hygienic practice to wash the cap every time after usage. So we just put it in water and like with the help of brush try to remove all the particles that the gel particles that it contains.
We have to make sure that these two things that you're seeing, the light branch and this is the branch, they are not supposed to go in the water, because it is a very sensitive part of the machine and it is just not good.
And cleaning all the electrodes with the help of the toothbrush, and there's a cavity. So you have to put the brush inside the cavity and try to remove all the residue gel that is, and that is how you. That is how you.
Any kind of restriction on the duration for which you can record the data?
Actually, if you perform this experiment in air, like a lot of AC or fan, then the
The gel gets dried easily, and so in that case, like after one or two recordings, the signals might get susceptible to a lot of noise.
yeah.
So in that case, you need to reapply the gel. But if you do
We
the
apply the gel or we need to rearrange the gel?
no, we can just
Rearrange, because like it sticks to the scalp. So we need to remove the hardened gel.
remove the hardened gel.
It's like salt solution. If you leave it out, it will dry. So if you are continuously recording on a particular person, so the gel will dry. So there is a cavity. With that, you can just fill some gel and again you have to remove the old. Good to continue. So it has a battery life of around 4 to 5 hours if you use it continuously. So cases here we are applying gel. There are also some dry gel alternatives that are available. So in them we have silicon tip that is attached. So we don't need to apply gel and put the electrode. We just need to place those silicon tips on the scalp and record the data. But the problem with those machines is that the data that is collected is not very high quality. So it has more noise as compared to active scalp.
Just ensure that all the electrodes are dried before continuing for the next recording once you have washed it, because this is something that we have observed, that when the electrodes are contains moisture, you need to put in more gel to
Because like there is a layer of water particles in between the scalp and the electrode tip. So we need to ensure to remove that.
there is no problem. That is a problem with the data collection, that if we don't have enough data for older population, our model might fail. But if we have a balanced data set of all the age ranges, we will be able to record for them.
So models, in the data collection, we've also got the age of the person, the handedness of the person, that is his right or left-handed, gender also. So these features can also be useful in for the model.
Which type of chemical you use in a gel?
This is a
It's just highly dense
solid
Potassium
solution.
chloride. It is generally potassium chloride.
KCl.
The name of
it's KCl, not written over.
What roles these gels are playing in this model?
It is just to reduce the impedance.
Okay, impedance. R square plus XL minus XC.